and welcome to Practicing PostgreSQL Joins. And today we're going to be practicing creating some tables, inserting data, writing some queries, mainly involving joins in PostgreSQL. I already have my workspace set up here using PSQL, I think it's called, and PgAdmin4. And they had some sample data that created the tables, which I've already put in. Essentially, there are 4 tables that relate to one another. One is the customers, one's the products, one's the orders, and one is the payments. And then there's sample data in there for all of that. The first thing we're going to do is the inner join. Let me get rid of this here. Actually, let me make sure I copy the cross join. Just a moment. All right, so I have copied each of the queries just so I'm able to do it in a video. The first one is inner join, like I said, so let's just paste that in here and talk about it. As is pretty standard, we are starting off with a select statement, and then we have aliases for the different columns, which will help us out later. So C is going to be customer name, P relates to product name, O for order date, um, and yeah, we're doing it from the orders, so that's the main table we're looking at, and we're going to perform the inner join, which means that only rows where there's a match uh, in both orders and payments uh, are going to be displayed in the result. So we're interjoining orders and payments, and we're going to do it on order ID. Um, what's nice about PgAdmin is it breaks down the columns and such. So order ID, and this tool really helps because the sample data was just kind of in text format. It wasn't visualized very well, like with the columns and so forth. So you really had to kind of play around with it in SQL to get a better perspective, which I imagine is going to be standard in the industry. Um, uh, yeah, it was a great exercise, but yeah, we did that, and then we also interjoined. We did the same thing for the order and the customer and the product. So here we go, product, order, customer, as you can see. And then if we run that, um, this is only going to show us where there's a match. So there you have it. Um, and this is not gonna, there was a follow-up for this one, which is why might an inner join not return rows for orders that do not have a payment? Um, and it wouldn't include orders with no payment because inner join only shows the common part between the two data sets. So if there's no payment, um, there's no commonality there, and that's kind of the use case of inner join really is that you want to really see what's actually there. We'll talk more about the other ones, like cross join, a little bit later here. Next up, we have the left join, and we want to retrieve a list of all orders, whether paid or not, along with the payment amount. I'm sorry, along with the payment date and the amount. So I already have the pre-made SQL for that. Let's take a look at it. This time we are selecting the order ID, customer ID, product ID, and order date from the orders table, and from the payments table, the payment ID, date, and amount. We're going to use the from statement for the orders table, and we have the aliases just to help us out here a little bit. And then we have the left join, which is going to take that. Left joins are, it's funny that they put the left join before the right join because the right join is a lot less common. So essentially, if we run that, um, here's what you're going to see. And then the follow-up was identify the order ID that does not have a corresponding payment, which columns are null. So this uh, here, as you can see, there's a null value here. So what we would do is we just add a where to that and give that a run. As you can see, only the null value is displayed. And then let's move on to the next one, right join, which is the tricky one. For this one, we need to create a query that shows all payments and any matching order information, even if the order somehow didn't appear in the orders table, like if it got put in there mistakenly. So that's a lot more than one row of data that we could expect to see. For this one, as you can see, there's a lot more columns for the select statement. Pretty much everything from payment, and then 3 of the things from orders. There is a commonality there. The order ID is in the payment and the orders tables. So we would only need that once. If From there, for the orders, product, customer, order, we talked about the commonality there. There's another commonality between that and the products here. What is it? Product ID and the order, and there's a product ID in order and in product, so we'd only need to display that once. So all that's left then for products is the product name and the price. And for customer, the customer ID is also going to be in orders as well. And then there's the city too. So because it's a right join, we're starting with orders, and we're going to join payments uh, with its alias PM. Make sure to put it after, not in front. Order, uh, and that when we're going to equate that to the payments uh, table here, associating that with the order ID column. So that's going to mean that the left, I'll just run it here. So the left column is going to be the payment ID, and because we did our right join, the order is going to be over here, and it's going to continue to be there. And then after that, it's not like you can do another right join and another right join. It just doesn't really work that way. So then I had to do left joins to add the customers, to join the customers and the customer ID column, because we talked about the commonality there. And this is just me doing that. And the same with products. And it generates this. So we've got the cities, customer names, prices, and the payment ID is sort of the thing. It's all based around there. Let me take a sip of coffee here. Okay, so the follow-up for that one, um, discuss a practical scenario where a right join might be useful or if it might be avoided in favor of a left join. Generally, you're going to want to do a left join. um, this was a challenging question for me because right joins are a lot less common, and so it doesn't make sense, and it's kind of like a little bit backward thinking. So that was a little I don't know if frustrating is the right word, but a right join could be useful if you were, say, working on a fairly complex query, and then you realized you needed to do a join to incorporate a random unexpected value into there, and it would save you time from having to potentially start all over. So that could happen. Um, yeah, just would probably feel like left joins are a lot more common. And shout out to that. I imagine they're a data engineer on Reddit who kind of explained that, and they claimed that they only had to use right joins 3 times in their professional career. But it's good to have that kind of knowledge. Next up, we have full outer join, um, and we want to. Excuse me, one moment here. pardon me, for full outer join, we want to retrieve a result set combining all rows from both orders and payments and matching them where possible. Rows that don't have a match should null from the non-matching table. So again, I've already done the SQL, and we're going to be doing that using a full outer join. Okay, so this one's a lot less, it felt like, than the right join, and even the left two. To go back to what it asked for, a, a set combining all rows from both orders and payments. So we're just looking at those two. So we get all those columns in the select statement there, with the exception of, where is it, products. Oh no, I guess we are getting all of them. Yeah, because they want everything. So we're getting it all. And then we're going to say from orders, full outer join payments, uh, and of course the order ID is the connector there. So let's run that. And here is all rows from both orders and payments, matching them where possible. And it looks like they don't match in this instance, so we got some null values there. And this is useful for comparing two data sets to determine if there are discrepancies, which in this case there are. The payment date and the order date don't match there. Maybe there was like a delay in payment or something, or it's just not there, or maybe they didn't pay at all. I don't know if it was a refund or something, but you can dive down a little bit deeper. So it's a great tool for determining if there are, null, uh, duplicate, or unmatching. And by duplicate, I mean like one data set has two of it and the other one only has one, but you'd expect one from each. Um, just general discrepancies, really. So it's a good tool for that. Lastly, we have cross join. And for this one, we want to generate a list of every possible combination of customer name and product name using a cross join. So let's get to that. Just a moment. All right, a lot less, as you can see. Select the customer name and the product name from the customers table, cross join products, and boom, that's it. A lot more entries, as you can see, because what you're doing is you are combining all the possible cases there. It could be helpful in certain business or data science contexts for, as I say, A/B testing, but it's really just a great tool for creating a matrix, which can be used to display data in a granular way that can lead to useful insights, like just having this. I mean, if it's massive, you probably don't want to use a cross join, or maybe put something like a limit on there or what have you. Um, but yeah, just seeing this data presented in this way is good. I believe there are going to be, it's every possible thing. So it, it might not be ideal. It's not as specific, but just sometimes simply scrolling and seeing, okay, it looks like the laptop phone, headphone, and monitors. Maybe there's monitors are a little bit more popular, probably not. Um, that can be useful for that kind of stuff. So that does it for this assignment, and thanks for tuning in. Have a good one.